Now we are going to welcome a panel. So the panel will start with two presentations, and then there will be after two 10-minute presentations, there will be a panel discussion, and the topic is towards disaggregation in IP and optical networks. It's the Telecom Infra Project.
Thank you for introducing me. My name is Hiro from NTT. I'm a director of IP transport technologies in NTT. I'm from Japan. I had a big disaster the last Saturday, but I'm just 23 hours late for my flight. So now I'm here. So very happy to have a presentation here. So today I'm one of the co-lead of this subgroup, which we introduce and discuss about. Then, okay, let's start from introduction of this subgroup Candy. Okay. So this is today's agenda, including the panel discussion. So before introducing the Candy, so let me let me introduce about the background and our motivation. Okay, so this subgroup converging the IP and the optical. So let me introduce about kind of the main issues of the IP and the optical. So of course we have now big equipment for our carrier network. So about transport, so many functions in a black box, big router. So here is capacity, features, operation. So there's one box. So we choose a best solution for the one service. But when we add to the new features, we cannot add. That's kind of a problem for the NTT because we choose a best solution. Then we try to add this function, but here is a kind of a best volume of the configuration. When we add a function, so here is we have to add more configuration. But for carriers, so we need to keep reliability and a service. We have to continue the service. So now this is a kind of a main problem for the IP part. About optical, I'm not an expert for the optical, but I think so optical has not so many features, but optical kind of has a tight coupling, so this is a kind of a common features, OLS or open ROADM, and also they has a transponder. So, but the transponder's lifetime is more short. So, but we cannot change only the transponder. This is kind of a vendor lock-in solutions. So this is for NTT, kind of for our team. So NTT, we started this project, multi-service fabric. So just we try to disaggregate the big router to the kind of transport, fabric. And for the control this chassis, so just disaggregate this control function for the servers as a controller. Then, for example, the telephone service or video service, we just put to the clouds. So we started with big major vendors. So let's do that. But of course, major vendors keep their business. So we choose a branded switch, including Cisco and Juniper's a kind of pizza box switch. And also we included this white box and network OS, disaggregated part. But we cannot find any good controller vendors. So we decided to have our own controller in-house to show our requirement. Then next time, so we know that this kind of network OS. So that time we need a MPLS function for providing the L3 VPN, but no network OS for the white box vendors providing this kind of functions. So we started to develop our own network OS, maybe 3 years ago. So now we had these software. Then we introduced our commercial network, so let's do it. But this is just a kind of looks like a Galapagos. We need more partners to show our requirement to the many partners. Then here is a tip, Candy. So about 2 years ago, we had a discussion with the tip chair, Axel from DT. Then we showed our requirement, and we want to do like this. Then next year, finally, we established this Candy. So with this Oscar from Telefonica. Then we announced this establishment last year in the last TIP summit. Then only 1 year, we made a first POC in Telefonica's office. And we send our equipment for the IP part to Telefonica's office, and we conducted this POC and successful together. This is a kind of a Candy's position. TIP has about 12 projects. Then one of the projects, the OPT, Open Optical Packet Transport, they has many hardware or something subgroups. Then Candy is kind of an umbrella. So Candy proceeding the kind of a use case, and we define the architecture like this. So our goal is we want to enable the flexible feature allocation, not only IP, not only optical. We want to make it freely. Then we will deliver the use case and the design and the configuration. Okay, this is a current Candy's members. So in addition to Telefonica, now we have Orange and Telia here and Giant. Then some other operation companies, carriers, so have interest to join us. So here is Candy's one good point is providing the use case. So use case oriented, and we think what kind of architecture we need, what kind of open interface we want. So now almost 6 use cases. Then this is a current Candy's architecture. So including IP and optical. So I don't explain so detail today, but so we selected these kind of interfaces, and some interfaces under discussion. So this is an outline of the Candy. So let me hand to the Oscar.
Okay, thank you very much, Hiro, for the introduction. So now let's try to briefly, in 10 minutes, be able to tell you what was this proof of concept about and why is this relevant. So first of all, what are we talking about? Here is disaggregation here. Okay, so disaggregation in the IP and in the optical. What do we mean by disaggregation in the IP? So in the IP, it's just the functions, we are going to do the same function that we have been doing our whole life in IP, but we are just decoupling the hardware from the software. Okay, so that means with the same hardware, with the different chipsets that we can plug different network operating systems. And in the optical side, we are targeting partial disaggregation, so that means that the line system and the transponder does not need to be from the same vendor. So here we are talking about partial disaggregation because it means that we couple the transponders in pairs over the line. So we are partially decoupling that. And with that, for us is quite relevant. And also we are talking about converge because we want to operate the network as a whole. Okay, so this proof of concept is about having a full disaggregated network with a full SDN automated control. Okay, we know, and there are proof of concepts around, and even in production networks, we have been able to automate things, mainly coming from established vendors with proprietary interfaces. Here, everything that we are going to do in this proof of concept, the goal is to see how far can we go with open standard interfaces versus the proprietary actions. So here, our goal in this proof of concept is we are using a hierarchical control architecture, we are using standard interfaces. And which ones have we chosen? So for the IP, as northbound interfaces, technological ones, we have chosen ITF technologies, so basically using RESTconf, NetConf, and also service models, network service models, so it is not service models aimed at being for the customer, so it's just network, okay, so pure network, so forget about customer. That we will have upper layers to deal with the customers, and we have the TMF for taking care of that. So here is just focus on pure network, so it is the technological details. For the optical world, we have the transport API to be able to set up and expose topology on demand. So here we chose this ONF approach. And for the device configuration, OpenConfig was the way of describing and configuring equipment. So this was our main recipe. And this is the hierarchical architecture. So we have one hierarchical controller. I try to simplify this as much as possible, just to, as we have 10 minutes, not to bore you. This hierarchical controller to have the complete view and provide the controller or controllers for the IP, an optical controller, and for the line system, it will have its own open line system controller just to take care of providing a spectrum. Okay, so the role is just manage a spectrum, and then the optical controller will take care of configuring the transponders in the end, so setting up the power on off, changing the frequency, and controlling the OLS controller to set up the wavelengths. And for the routers and the white boxes, the goal is to use OpenConfig for that. So, is this feasible? Okay, let's do it and find out whether it is feasible. So we chose from the list of use cases, we started to choose, okay, for the first one, let's try to do an automatic end-to-end provisioning, including IP and optical, also be able to manage the optical spectrum, and also try to do a replacement of device. Okay, are we talking about disaggregation in the IP? We said that we can decouple hardware or software. Okay, let's try to do it. So what is for the first one may seem more obvious. This is providing, for example, a layer 2 VPN service that at some point requires a new bandwidth, so you need to trigger the creation of an optical connection for that bandwidth. But the last one may be more new, so that is, okay, I have a box, an IP box, with it's running, which is an operating system, and you want to upgrade it. Or even you want to change the operating system. You have run out of you prefer a new one, you change the license, so the idea is to, okay, you can divert the traffic, reinstall the software, and then from the controller, put down all the configuration, put it up, and everything works as before, okay? That is the use case for this network operating system replacement. So, okay, let's find out whether it was possible. So, what did we do? Okay, with the help of NTT, we took to our lab, we took 5 white boxes, 3 different network operating systems. We took 1 open line system. We took a couple of pair of transponders. One pair of transponders is commercially available transponders. Also, we took Cassini IP optical boxes, which in this case we are just using them as transponder. We took 1 IP controller. We took MSF that was mentioned before by NTT. We took optical OLS controller, which was provided by the OLS vendor. We took optical controllers. For that we choose ONOS to take it, and 1 hierarchical controller that we also took. So here, this is the setup that we that we had and here just to highlight that where did we find that it was feasible to do with open interfaces and where not. For example, with as we mentioned, we had 3 network operating systems, but just 2 of the network operating systems that were commercial, and the third one was Beluganus, developed by NTT. And in the one that developed by NTT, they managed to configure it by OpenConfig. So, okay, it is feasible. However, the 2 commercial ones, no. Okay, so just typical style, CLI, and or configuring everything in the classical way. So, it is feasible. Yes, okay, we demonstrated with the, but industry needs to do it. With the optical controller, transport API, perfect. That worked quite nice. Still some details to polish, but quite nice. With the transponders, okay, it worked almost fine. Okay, so we have a process of refining the drivers for the OpenConfig. So we also going to go see later which are the relevant findings, but in principle we saw that the OpenConfig support was sometimes not as complete as we wanted, and there were some minor additions to the standard that makes the interoperability a little bit more complicated, but it is feasible to do it. So what did we accomplish to do? So the automatic end-to-end test of a layer 2 VPN service provisioning that included triggering of an optical connection. So this was, the workflow was completely automatic, and it was done successfully. So that worked, using the transport API to trigger the optical path, using the OpenConfig to configure the transponders, and the ITFL to VPN service model to describe the service. So that worked nice. Okay, setting up the boxes with standard OpenConfig was okay only in the Beluganus. In the others, we had to do it with the configured equipment with the CLI. The network operating system and upgrade replacement, we did it, but okay. So just important here. So what we were able to do is, okay, shut down the box, install the OS, boot it, and then the controller configured it. Okay, but what we did not do was to be, or still missing, this is the challenges, is that automatically send a command to the node, say, hey, please, I'm going to replace your OS, shut down, be ready to ask for the new config, and when you boot, get the new OS and boot. Okay, that still is not possible. Okay, so right now we had to reboot, install, and then yes, everything was configured with the new OS as it was with the other OS before, but it still needs this manual process. The optical service provisioning using the transport API, that worked nice. The media channel provisioning was fine. So the just difference between the two of them, the first one is from client interface to client interface. The second one is just a pure spectrum. And the challenges that we found. The OpenConfig implementations in the commercial devices were not fully complete. So we still need to tweak and to discuss with them, okay, please go this direction, don't do these proprietary things. The white boxes, the IP white boxes, they did the commercial software for white boxes did not have yet OpenConfig support. So I think that's something to be improved. For the NOS replacement, we had the two main issues. Was one of them that I commented before, that there is no automatic way yet to tell, okay, uninstall current software and install the new one, and that the license in one case was locked to the Mac. Okay, so changing the OS freely was a little bit complicated, and we had to find the issue to solve the Mac, so which because the license is locked to the Mac. So also another problem is that the different implementation of the network operating system, some of them were not compatible between each other at the VXLAN level. Okay, so for example, for the leaf and spine configuration, the leaves could not be from different OSs because the implementation of the VXLAN was not compatible with each other. So we had some problem there. Also, there are some, with the information that was provided by the optical controllers, the topology information was somehow limited. So only the endpoints were, at this point of the implementation that we had, were exposed. Also, the type of transponder was not exposed. So it means like, it doesn't matter the vendor that they were like exposed transponders. So in theory, you could configure any to any, while that is not possible. Okay, so we need to expose that too. Also, there was no auto-discovery of the link between the open line system and the transponder. So that was needed to be added manually to the controller, so that he knew that this link exists, so they were not automatically discovered. So this shows the good things and also the things that need to be improved in the industry. So with this, just some acknowledgement of all the companies that participating in the company. So we had EdgeCore providing the white boxes, IBM Fusion provided software for the Cassini, Honors contributing for the OTTN project for the optical controller, the Metrohall project provided the hierarchical controller, and the operators provided the use cases. So with this, I think we can go and start our panel discussion and around disaggregation. And also, if you have any questions, you can ask them later after the panel, or just look for me after this. So we will publish a white paper later with the technical details. So here, just would not want to enter into much details. So we can go for the panel now.
Good afternoon all. My name is Don and I'm from ABI Research. I'll be the panel moderator today. Thank you Oscar and Hero for the presentation. On the panel today we also have Tobias from Matthias from Telis. Now the panel will take 25 minutes. We'll take 20 minutes for a discussion between the panel here and 5 minutes. I'm sure there'll be some questions from the audience because this is a very interesting topic. Now, when we are faced with new phenomena, the purpose of the panel is to delve a little bit deeper into how can we embrace these new technologies. I mean, when we're faced with new phenomena, I think there are two ways to go about it. Either you start everything from scratch, in which case then they require a lot of resources, or you mirror somebody else's work. And in this case, we have 3 operators that have done a great deal of work. So, to kick things off, perhaps, what is the motive behind doing this? Why embark on this project?
I can at least talk for our company, and really, you know, in a perfect world where all suppliers would be absolute perfect and price per megabit would be the same everywhere and everyone had the same features, you know, we wouldn't need to do this. It would be pointless to do this. But of course, we are sometimes stuck with a supplier that's getting behind the others, and then we feel, you know, ooh, we would dearly love to buy that piece right now because that's absolutely the best on the market and has the best price. And of course, in the wholesale carrier world where we fight for cost per megabit every day, we might be stuck for years behind something where we don't feel this is the best solution we can have on the market today. So I think, you know, the biggest driver for us is, of course, that we would much more like to pick and choose the best thing at the best time at the right time. And if we can do things like this, where we can control our network much better and we can swap out network pieces in a much smarter way, that is absolutely the biggest driver for us. It comes with a lot of difficulties that we can talk about, but I would say the biggest driver for us is, of course, being able to buy the right equipment at the right time at the right price with the right performance.
Absolutely. Oscar, any thoughts from you?
Yeah, from Telefonica perspective, we also started with a similar motivation. We saw that there were, for example, for the optical part, the life cycle of the optical line system and the transponder was different. So, for example, when we installed the line, it typically lasts for years, so because it's typically bound also to the deploying of the fiber. And what we are doing basically is switching a spectrum, while the transponders, well, you've seen all that, I guess, hearing all the people here have seen the traffic evolution. So, I don't know, since I started in this business like 20 years ago, the traffic has doubled every year and has never stopped. So I don't know why, but it has never stopped. So that means that we have had to change our optical transponders every 2-3 years. We were growing and growing and growing. So that means that we are continuously replacing transponder, and there the technology changes a lot. So now we were very tight, the transponders and the optical line, and we could not get the advantages. So for us, being able to interchange, it was a good motivation for the optical disaggregation.
Thanks, Oscar. So the traffic has certainly doubled, but telco traffic, as we all know, traverses multiple domains. Here, a question here is, what are the best places in the network to do disaggregation? Where do we start, I suppose, and then at some point perhaps move it further in or further out or further to the edge? How do you see this?
Yeah, I believe the good scope is a kind of a, the large, wide network, and we need such kind of the devices which need a capacity. So, because for access side, I think this kind of disaggregated technology is very good, but at the same time, I think it is kind of easy because this is not so big capacity, and this feature is just a kind of a specific. Then, but about a wide area, this is the core instead of a core router, or this kind of big optical network. So here is a very challengeable point, I believe. That's why I choose this area rather than access.
Thanks, Ciro. Oscar, any further remarks to that in terms of where specifically in the ecosystem do we apply disaggregation?
Well, ideally we would like to apply it everywhere, but taking into account the trade-off between maturity of the solution that are right now and the level of performance that we need, I would choose the places that right now are, let's say, more in the edge of the network. So let's say the first points in our transport network that the requirements in terms of traffic are not as big as deeper in the core. So it's I think that range is where we are starting, and then go deeper into the core as the technology matures.
Yeah,
I think we will absolutely start in the core. I think that's where we see the biggest benefits, and that's where we can see really see the business case flying for us. So I from our point of view, and obviously being who we are, and lots of focus on the big carrier segment and the long distance network, of course. But I would say, if we can find a good solution for buying various types of transponders into open line systems in that long distance core, perfect. That's where we want to go.
Can I add one? So for the kind of a router access part, so even one operator has many numbers of the devices. So maybe vendors likes to introduce this kind of area because the number is huge. But for about a core, so if we introduce a big router, the number is kind of limited. So maybe the vendor cannot provide a very difficult decision to contribute to just one operator. That's why we need this kind of ecosystem for the core core network.
Thanks, Hiro. So network flexibility and openness, no doubt, is bound to be a key driver for telecoms industry. And now you all work with vendors. Now, how does a model like this fare with the current model, where you are supplied with top-to-bottom integrated solutions that meet the performance and isolation requirements that telco operations have? Cloud native, agility in innovation, speed, great. Does that meet the telco specific requirements that we need? Perhaps.
I can start on that, and this is of course very different from the way we have operated before. So it's going to be a huge challenge both for us and our vendors. Of course, we're used to having one vendor even in one continent, and every time you have a problem, you know who to call. It's very simple. It's not your problem, it's the vendor's problem, and they will fix it for you, and they charge you for it, and that's their business model. Of course, now when we will start to mix and match, there comes the operational hazard immediately. Who will blame who? When something goes wrong, someone might say, it wasn't my transponder, it was that transponder over there who had too much power sending in. And so we are absolutely in for a completely new game. What we're doing on our side is, of course, we need to add more resources. We need to add more skilled optical IP deep knowledge resources. Traditionally, 10 years ago, telecom providers like us, we just outsourced all of that to vendors, and we said, we don't need that. We need business people who can find cool new things we can sell. I think those days are still here, but we now need to bulk up again with the optical skilled people. If we're going to manage solutions like this, we need to know if something goes wrong, what is wrong, and can we really say that that's the problem. That is a very, very different thing from what we are used to. So, of course, that's new for us, new for the suppliers.
It certainly is on both sides, both supply and demand. Oscar, any further remarks?
I just want to add that, yes, we do want the technology back to our operations. Now, with the coming of SDN, it seems that we are having, again, this knowledge, at least as you can see, in all operators, they are bringing software knowledge to the company, so they are bringing engineering knowledge to the companies. So I think that we need to regain the technology. And regarding what happens with the current players, yes, we will have to keep working with current players, but people will have to adapt to the new market, and people will have also new opportunities. So this gives more business and more ways of differentiating, because now, for example, you have new business of software for boxes. So this opens new opportunities and opens new business. So I think this is an opportunity for companies to provide bigger value.
Yeah, it certainly is. So this paves the way for, I think, we have 3 operators on the panel now, and I think a key question is technology is one thing. Being in a position to absorb that technology is another thing. So how ready are you to change internal structures and processes? Because I think process reengineering is a massive, massive endeavor, multidimensional. Perhaps Matthias.
I wouldn't say we're ready at all. We are getting there. We're understanding it right now, but of course we have a long way to go. Having traditionally tried to outsource everything that has to do with technology and software in the past, and only focused on sort of other things. Now, when we need to start to sort of move all of the things back, that is a big change for us, absolutely a big change. It's being done. I think we started like a couple of years ago, so we're halfway in there, but we're far from done. It is a major change for the network operational department in our companies. I think the front side of the company, that's still the same, but we need to take control again over our own network and define our own destiny. And that is absolutely a big change, a very big change.
Hiro, NTT has done some great work and is very involved with this, this new. How do you see this internal change that is required to best capitalize on the opportunity here?
First of all, as an engineer, I think the vendors also needs our skill. because they don't want to talk about it, talk with the people who don't know any technology, right? So we have to know that we have to have a skill and anything. And especially, I think, especially for NTT, so IP part for the IP guys needs this kind of a skill, and we have to know about software and hardware about IP devices. For the optical, so they in NTT they can decide a specification like a OCP, so they can design the hardware, but in the IP part, so there are thanks to the big vendors, so we cannot design such kind of a hardware and software so far. So now we just challenge to the this kind of software. And now we are gaining the kind of skills and knowledge about the hardware and how to control the hardware. Then why many vendors say this cannot do that? Oh, now we agree.
Thanks.
I can just give you an example. In 1995, Telia was 49,000 people in Sweden, and now there are less than 6,000 left. 20 years, 43,000 have left the company, and it's not the business people that have left. It's the operational piece and the engineering and all that stuff. So of course it's a big challenge now to get back into that game. Of course you don't need 43,000 people to do this. You can, but you need software skilled people. Telia have sold off software parts of the company to others. So that's it comes with a big challenge right now.
Oscar, Telefonica is an operator that is sort of leading in some of this. I mean, OSM, this project, Unica. How do you see this from internally? I mean, are there any initiatives to sort of equip people with the right skills there?
Yes, definitely. But I don't know if as much as I wanted to,
right.
But definitely, I mean, we have taken into account the journey that we have done in Telefonica. In Telefonica, it was like 30 years ago, we developed the ATM switches. So we developed the switch, the thesis systems. It was developed by Telefonica. Telefonica developed hardware. We had white rooms to develop things. Then we said, no, okay, it was not profitable just to do it ourselves. It's better to say vendors, okay, do it for the whole market. Okay. Then we said, okay, we can do software. Okay, we can do the management software and so on. We started to do it for ourselves, and then someone said, this is too expensive to do it for ourselves. Okay, so it's better. We sold it to Ericsson, to Nokia, we started to sell everything. Okay, perfect. So then we are now, and we say, oops, then it seems that we need to, again, to do the things. But we said, okay, let's try a different way. Okay, so what is this different way? So this different way is, okay, let's collaborate. So this is why we started, and we say, okay, we are going to hire people, we are going to have developers, but this is going to be a community effort. Okay, so this is why, for example, OSM is an initiative across industry. So it's not just Telefonica pushing there. So we are now specifying the standards, specifying the interfaces. So we do not do it ourselves. We collaborate with the community. For example, we have just created the standard for layer 3 VPN creation. Okay, so we collaborate with the industry. We join with Vodafone, say, okay, you have the same problem as us. Okay, we get top model operators, Bell Canada, Orange. So we get all together and we start doing the work. So we hire people, we start this initiative, but they are shared between the operators. So what we cannot do is just, okay, all do it ourselves. That in the times that we are having, that seems not to be possible. You need to partner. It is all ourselves impossible.
Thanks, Oscar.
Let me mention about the disaggregation. So we cannot write a software for a complicated big router. We don't think so. So first we have to disaggregate, and if we use a pizza box switch, just one ASIC, just one CPU, very simple. That's why we can write our own network OS.
the universal divide and conquer. So a key strand in this discussion, and I suppose a key strand in pretty much all industry endeavors, is standards. Something that's there, but we don't typically think of. Standards in telecoms, long cycle times to next-gen technology. In IT, faster. Now, how do we combine these two so that we meet telco-grade requirements, but we do not retard speed, efficiency, and agility going forward? Perhaps Matthias, maybe you can...
No, I think that's a very important thing. Obviously, we all would love standards, but standards takes time, as you said, and especially when we have a number of companies out there today that could care less about standards because they just want it to super fast. So it's a very tricky thing, and I think this project here and other projects like this are typically getting stuck at just standards because each transponder vendor have different standards and they are not super happy of sharing everything. Of course, they have their secrets and they don't want to share, and we typically end up, I think what Oscar showed here, some of the failures here is typically because we didn't know everything about it because no one dared to tell us or wanted to tell us. So I think, we will absolutely need standards to disaggregate. At the same time, it's hard for them to give out their super secrets. If they have something new that's going to revolutionize, why share when they can make money for it in a couple of years? So it's difficult. And then at the same time, the train from others are just running and they could care less. They just build the cheapest thing. and they can throw hundreds of resources in there to just fix some things, while we can't really. We need to cooperate, and cooperation takes time.
Absolutely. It's certainly challenging, but we ought to start somewhere. Oscar, do you have anything to add to this?
And you mentioned before the long times that the standards took in the telecom industry, and well, mainly it was because when we did a standard, it was meant to be there for years. Okay, so we said, okay, we want these boxes to talk to each other. Okay, we make a standard, so we wanted to make it right, to make it properly, and to make it happen. So, but now with software, I mean, people is okay. No, I made a change, then everything changes. Okay, we recompile, we change the API, and people. I remember when I started playing with OpenStack, it was like when you finish doing something, then you see that the API had changed. So it was a pace completely different than us. So now we are starting to feel this as we are softwareizing the network. That we want to produce standards for that, but we are not fast enough. There are some exceptions. For example, take Open Config. They embraced the new. I mean, it came from Google, so they embraced from the very beginning an agile system. So it's a JIT. So you just you launch an issue, you discuss it, and then you apply, and you do a JIT commit, and then people approve it, and then it's quite agile in the way it works. ITF and ONF still follow this longer process, but now they are like starting to take a slower time. But for example, in ITF, I did some standards that took 5-6 years to complete. So okay, come on, in this time, in 6 years, you might have changed API 6-7 times. So it was too slow. So I think the standards bodies need also to evolve to this speed. And sometimes I'm seeing that it is the open source community also that is driving the standard. And even sometimes just not the open source, but some project or some community that was successful made the standard also available there. But definitely in the telecom industry, we need to be faster in producing the standard. But for us, in the times being that we need to share the cost between the whole industry, if we don't follow the approach based on at least open or standard, I think we would get stuck with integration costs that we cannot afford in the times that we are running now.
Yeah. Thank you, Oscar, and thank you, the panel. Does anybody from the audience have any question here to pose for the panel? Thank you. Yes, please.
Yes. Well, my question is regarding the transponder that you mentioned, because regarding with the optical domain, there are few companies who deploy or who build the white boxes. I mean, for example, one transponder of 100 feet. Here you mentioned maybe transponder for long haul, and maybe it's not easy to build a transponder or to have a transponder for long haul. So, what's your expectation regarding that? Because when you are going to when you go out to the market, you don't find a transponder for high capacity and for long distance.
Absolutely, and you're absolutely right. It's not super simple, but sometimes I feel, we can see now we have line systems in Europe all over the place, and I know I would love to buy transponders that fits into those systems, and thereby lowering my cost per megabit. I don't think the performance is it's really the cost per megabit and that stuff. So I think that's really what we're after. It's not a simple thing. It is quite difficult to find new transponders all the time that's going to work, but I think we still have 6-7 big vendors out there that can do these transponders, and my dream is just that I can, on a quarterly basis, select the one of the 6 that is the best for the moment. That is kind of what I'm after. It's not a simple thing. I also obviously understand that if someone is making the complete line system, including everything and transponders, they can probably squeeze 10% more out of that system because it's sort of super tailor-made, perfect. I understand when I start to mix and match transponders that I might lose some of the throughput capacity. That is something we have to live with, of course. So in some way, part of me obviously still wants to buy these complete tailor-made line systems to get the absolute maximum amount of megabits out of that line. And especially in US, where there is a super lack of fiber everywhere. Europe have more fibers. I shouldn't say that we ever consume, because then we will do it. But in US, there is a complete lack of fiber on many distances there, and of course we need every megabit we can squeeze out. But you're right, it's a difficult thing.
Yes, let me add one thing here. What matters most in the cost of a transponder is just the volume of production. As you say, these big ones, these high-end transponders that we are using, they cost more, but they cost more also because they are producing lower numbers. So one of the things we learn also is, okay, we can try to, lower a little bit the expectations and also merge with other markets. And for example, when we saw some for the metro region, our transponders, and this transponder that people is using for data center interconnect, they cost 10 times less of this, no, because they are for data center interconnect. And are they different from our transponders? No, let's check which capabilities they have, because they bring in buy in big volumes. Okay, so let's sum up. Okay, we can also use them. Okay, they same light, they modulate. They don't clash with other transponders. So okay, if they use the same gig, we can the same spectrum. Okay, why can't we use them? Are we so telco grade? We are so special not to use them. So maybe there also we need to rethink also from ourselves, and this is why we're also trying to open the line to see. Okay, this is my line. Can I put this data center interconnect transponder also for my traffic? Before I couldn't do that. Now I can if I do this aggregation. So there is a way that I can reduce the cost significantly. Maybe for the high end, maybe we can do that. But for most of the network, I think we can do it. And sometimes if we need to lower a little bit the expectations of a transponder, we'll have to live with that.
Thank you for the question. I'm not sure if there are any more questions. We are. Do we have time for one more question?
Just one, yeah.
Yes, please.
Question. Matthias has said that in the good old times, or as it is probably today, when you have a problem in the network, you just call
Absolutely. No, I think we have to look at all options here, but that's absolutely a possibility that the one that's going to run the optical controller will be the first one that can tell us where the problem is. Yeah, you're very right. We need to rethink this completely and also learn ourselves. We need to be extremely much better in our own operation center to clearly see where the problem is. Today, you know, when the lamp starts to blink red, then the phone numbers come up and we call and hope. We need to be much better tomorrow doing that analysis ourselves, but absolutely that person will also be heavily involved in helping us.
Thank you, audience, for the questions. Thank you, the panel, for your time and for a very interesting project here.
Okay. Thank you very much.
Yeah, thank you very much for all of us. Thank you.